Good afternoon, everyone, or good evening, depending on where you're joining us from. My name is Sam Nasr, as Shannon had mentioned, and this session is on artificial intelligence with T-SQL. A little bit about me. You can find me on Twitter or X at Sam Nasr. I've been a software developer since 1995, and I'm a senior software engineer and instructor for NIS Technologies. I've also been certified with a few certifications from Microsoft. And one of my favorite things is to run the Cleveland C# and VB.NET user group, as well as the .NET study group. In addition, I've authored multiple articles for Visual Studio Magazine, Twilio, and I just finished a course for LinkedIn Learning, and I've been a 6-time Microsoft MVP. A little shameless plug, if I may, about the Cleveland C# VB.NET user group. The meetings are free of charge, and we meet every month. The meetings are also open to the public, and we cover a variety of topics related to .NET. You can find meeting information posted at meetup.com at the link listed at the bottom of the slide. And so with introductions aside, let's get into why we're here tonight. So first question is, why use AI with T-SQL? I mean, after all, we do have a variety of different frameworks and languages that can help us build a model. Well, what's the advantage of using it in T-SQL and in SQL Server? Well, first of all, you're using the existing data that's already in the database. So you don't have to import anything. You don't have to connect to any remote databases. Everything is already there. In addition, you have integrated functionality with Python and R libraries. Ever since SQL Server 2016, and R and Python functionality has been added in over the years. And now we have full functionality using Python where we can actually integrate it into stored procedures. And so we can do all this by building the model, accessing the data, and training it, all done using T-SQL commands, which we're already familiar with, by creating stored procedures and then storing everything into the database. And so looking at everything from a bird's eye view, we're essentially able to fully manage our model, meaning we can train it, we can test it, we can store it into the database, and then we can use it to make predictions. And all that is in one-stop shopping within SQL Server, all using T-SQL commands. So this is available to us because of the extensible architecture within SQL Server. We already have the familiar tools for development, i.e. SQL Server Management Studio. We have integration with R and Python libraries. Pardon me, I had to go on mute, still fighting a little bit of a cough. As I was saying, we have functionality that's integrated in for working with R and Python. We have the ability to scale and optimize our solution within the database or growing it to a cluster. In addition, within SQL Server, we also have the ability to do analytics while staying close to the data. So we have everything there, and we can perform analytics on the data that we already have. And we also can leverage security features that have been available in SQL Server since its inception. So all this extensible architecture gives us the ability to be able to utilize AI within T-SQL. Now, how do we actually do it? First of all, you would need SQL Server 2016 or later, and you would need ML services or machine learning services. In addition, you would need to utilize Python machine learning libraries, which would be a separate installation process. And then we implement these ML operations using T-SQL or in stored procedures. We essentially create a stored procedure that accesses the Python libraries, and then we're able to store that stored procedure into the database and then execute it. And so because it's a stored procedure, it's going to be optimized, and it's going to give us the ability to reuse it multiple times, as well as the ability to have it being called by other procedures or other applications. So for our setup process, what we need to do is essentially go through a pre-installation checklist, which we'll cover in just a little bit. And then we need to install ML services, and then install the runtime packages for Python. Python or R, but for my specific examples, I'll be using Python. And then after that, we need to configure and debug, and then we're off and running. So 4 simple steps. But taking a closer look at the very first one, the pre-installation checklist, it's a little bit daunting and I won't go through it in detail. However, it kind of reads like a contract or a flow chart where if this, then that, and you have to maneuver through depending on which version of SQL Server you have, which version of the Python libraries you need to install, whether you have always on availability groups or always on failover clusters. So there's a lot of little things to maneuver, but it's all documented on the Microsoft site. The installation for ML services. Now, as you're running through the installation for SQL Server, you're going to be presented with a screen like this for the feature selection. You'll notice that in the center where we have shared features and machine learning services is crossed out. If you take a closer look at that, you'll see that this is the standalone version. And the reason we have that crossed out for our specific scenario is because that standalone version means just that. You're going to be creating a machine learning server that's going to be standing alone by itself, and it's not going to have the other features. What we want for our specific demo is the portion that's highlighted up on top, where we're installing the database engine, as well as the machine learning services and language. So the top portion is what we want installed, not the middle portion. Everyone with me so far? I can almost hear the heads nodding across the distance, but I should also mention, feel free to jump in at any point in time with a question or a comment.
So far, so good.
Excellent. Thank you. So moving right along, as part of the setup process, the other thing that we have to do is install our runtime libraries for either Python or R. And again, it varies depending on which version of SQL Server you have and which version of Python you'd be allowed to install and run on it. So again, this chart is over from Microsoft documentation. And then with Python, we're going to be using the RevoScale Py, which is the package that's going to be used for the data transformation and manipulation. So we're going to be using that primarily, as well as Microsoft ML that is also installed for this particular configuration. Once I have all that installed, the fourth and final step is the configuration. And what that entails is executing a store procedure to make sure that we have the right configuration value in place. So spconfigure allows us to be able to view 25 different configuration values. And as we see here, the one that we're more concerned with is number 10, external scripts enabled. So that has a minimum value of 0, maximum of 1. The config value that we have it set to is going to be 1, meaning that we want to execute external scripts. So this is key in order to be able to call Python libraries outside of SQL Server. Once all that's done, the process that actually happens on the back end is you have this flow that goes from left to right. So you have the SQL Server process. It calls out to a launchpad.exe. That launchpad then connects with a launcher.dll, which then connects to the extension process for the language executables. And then in step 4, it calls over to the BXL server, which then calls the SQL satellite.dll. Obviously, I'm not expecting you to memorize all that. I'm just showing you the flow where essentially what's happening is we start with the SQL Server process, and then as we make a call to the Python libraries, it proceeds from left to right, executes the Python. We get the results from the Python runtime, and then it goes back in reverse order and back to SQL Server again. So it's basically a loop going from left to right and then back again. So that's the architecture of what's happening on the back end. Now, when we actually want to develop a model, this is a cyclical process where we're developing an AI model. So think of, if you're new to AI, think of it as if you were teaching a 3-year-old how to identify something, identify a phone, identify a cup. You show them different examples of it and say, this is a cup, okay? And you show them multiple examples until they can actually be able to identify it. So you're training it, and then you're evaluating the model repeatedly. So having said that, essentially the first and most important crucial step in the process is collecting and loading the data. So we load the data, then we create the pipeline as we see over on the right-hand side of the chart, and then we train it using the fit method. After we're done training it, then we call the evaluate method to see how well did it learn on the data that we gave it. If the evaluation is positive and we're satisfied with the results, we can then save the model as we see down at the lower portion of the slide. If we're not satisfied with the evaluation, the process continues again, where we load more data, create the pipeline, train it, and then reevaluate it again. So eventually, to fast forward, we want to get to a point where we can actually save the model and be able to execute it. Now, when we're saving the model, once it's saved and we want to use it, we essentially load the model into memory, and then we pass it in a value that we want it to predict on, and then we get that evaluation back or the predicted value back to see how well it did. And this could be for home prices, for a variety of different things. So you're training it on some data, and then you pass in a value to predict, and then you get the results back. And that's how you would use the AI going forward. Any questions so far?
Not yet, none for me.
Good for me.
Very good. All right, so moving right along, the best way to explain things is by a demo. And so let me bring up SQL Server Management Studio. And so if you recall, there was a variety of steps that we had to go through, right? We had to do the installation. We had to do some configuration. So I'm not going to walk you through the sitting and installing things over again, but rather let's just jump to the configuration step. And if you recall, there's an SP configure that we need to utilize. If we just execute that by itself, it just simply displays the values of 25 different configuration items that we can set. More specifically, the one that we're concerned with is this external scripts enabled. And so we include that in our call for the store procedure, where we're going to execute SP configure. We're going to pass in as a string the name of the variable that we want to set, external scripts enabled, and we're going to set it to a value of 1. And then we're going to reconfigure with override, meaning these are the new values that we need to use. So as you can see here, I already have it set because I've ran through this demo before, and so everything's already set for me. Now, moving into a very light demo. So what I have here is a demo for housing data. And let's change databases. And so I have a table, and I kept this very simple as a introductory demo. Essentially, all I'm concerned with is the square footage and the price of a home. That's all I'm going to house in my data, in my table rather. Obviously, if you've purchased a home before, you know that there's a lot of other factors that influence the price. The number of bedrooms, whether it has a basement, whether it's a finished basement, a pool, a fenced-in backyard, et cetera, et cetera. The list goes on. Pardon me. However, for demo purposes, we're just going to focus only on square footage and price. And so I'm going to insert some records into that table. And let's make sure that my table is clean. So I'll delete from there. And then I'll reinsert these 4 records. And so I just have that in there alone. Now, I want to be able to create a store procedure that actually is going to do linear regression on that data. And it's going to store the model. And so let me expand the screen a little bit. So this is the store procedure that I'm referring to. Walking through it step by step, I'm going to create a procedure, and I'm going to call it generate sale price pie model because I'm using the Python model. And it's going to output a trained model, which is a var binary max. Think of it as a string. The store procedure, I have it where it's going to be executing an external scripts. The language specified is Python. And then from here, I import my library from my modules, and I specify that I'm going to be importing pickle to be used from Python. Then from there, I pointed to the list of the columns that I have, and I specify that my target column is the price column. I want to execute a linear regression model on it because I've already done analysis on all 4 records, and I know it's utilizing linear regression. And then I'm going to use the fit method to be able to train it. And it's going to be looking at the columns as well as the target. So I have my columns, which is square footage and price, but more specifically, my target is the price. That's what I wanted to be able to predict in the end run. And so after it's done training it using the fit method, then what it's going to do, it's going to dump this out into a variable called trained model. And this is going to be a serialized string for all intents and purposes. And then from there, I output this trained model. So that's all my store procedure is going to do. So let me go ahead and drop that procedure. And we'll go ahead and recreate it again. All right, now that that's created, I still don't have my model, but I have a store procedure that can actually create it. So now I need to actually execute that store procedure. But the catch is, when I execute that store procedure, I get a var binary max output from it. What am I going to do with it? I need to store it somewhere. So I have a table called sale price pi models, and that's where I'm going to store that model. All it is, it's basically a table that contains the name of the model and then the var binary max of that model, meaning that serialized string. And so to make sure that I'm working with clean data, what I'm going to do is I'm going to drop that table and then recreate it again. Pardon my cough. Now I have a table that's ready to store and house that var binary max. I need to execute the store procedure and then take that output and store it in there. So this is where it's going to happen. I'm going to declare a variable called model, and it's going to be set as var binary max. I'm going to execute my store procedure, and you'll notice that model is my output variable that I'm passing in. When I get this output model variable, now what I'm going to do is I'm going to insert it into my sale price pi models. Okay, so because I'm working in SQL Server, I only have store procedures and tables to work with. So I'm using the store procedure to create the model. Once I have that model, I need to store it into another table called sale price pi models. Okay, so I will go ahead and execute that portion. And it's going to take a minute. But while we're waiting on that, let me pause and see if there's any questions so far.
Nope, not for me.
All right. So as you see in my output, I have a whole bunch of texts, which essentially, if you recall from the diagram earlier where we showed the architecture, as we make a call from SQL Server and it goes through the SQL satellite and the launcher, and then eventually goes back again. That's essentially what we're seeing here, is all these messages as the scripts are being called and then it cycles back again. But the end result is I have one row affected because now it's stored it into my sale price pi models. So when I do a selection on that table, there I have the model name that I gave it, called it linear underscore model. And then here's my var binary max model. So this is the algorithm right here, the model that will actually do the prediction. So now that I have it, how do I actually call it and be able to create a predicted value? And that is, as you might have guessed, that's also done by another store procedure. And so here I have another store procedure called pi predict sale price count. And so what this is going to do, it's going to be a procedure that actually executes that model on those values, and then it's going to produce a third column where it's going to show me the predicted value. And so to walk through that stored procedure in a little bit of a slower pace. So here I'm going to create the stored procedure. And again, I'm specifying that it's a Python script. And then everything you see in red is essentially Python. So I'm importing from the pickle library and the panda library. And here I'm loading my model, my Pi model. And this was passed in up here where I do a select model from sale price models where model name equals @model. So this is the model that is being passed in as the input variable. Then from here, it looks at the data frame or all the columns listed in there. It looks at the price column as the target, and then it's able to make a prediction based on the square footage and the price and what it has learned, and then it outputs that result set. So now I have a result set. You'll notice that it includes square foot and price, but now there's a third column called sale price predicted. So this is where I execute the model. It's going to look at the square footage and the price that it had been trained on, and it's going to create an additional column called sale price predicted. So this is the evaluation. And so when I execute this, actually, this is already stored in memory in the database, so I don't have to recreate it. However, what I will do, I will drop the Pi sale price predictions, and then I'll recreate it. So that way I have a clean table. And now what I'm going to do is call that store procedure and then insert those values into the new table called Pi sale price predictions. So I'll go ahead and execute that. And that completed successfully. Now, when I do a selection from Pi sale price predictions, there we see the square footage that was initially entered, the price that goes along with it, and then the predicted values. And as you see, it's almost a one-to-one correlation of the price with the predicted price. So this is a time where you stand up and applaud and say hooray. And so this is where we actually were able to create the model. We stored it, we trained it, and then we were able to, thank you, Rochelle. And then we were able to actually run through the data and then produce a column for sale price predicted, for sale price predicted. And as we see, it turned out very well, where we have a very, very close relationship between the predicted and the actual price. Okay. Let me pause here and see if there's any questions.
I have a question.
Please.
When you're running this Python, how do you debug it if it doesn't work? Like, is it gets executed when you call the stored procedure, right? So when you create the stored procedure, there's no like syntax checking or anything like that. How do you know if you have an error?
Are you assuming that I would actually write bad code, Shannon?
No, I'm thinking more about myself.
No, I'm kidding.
You probably never run into this problem, so you may not even know the answer. But when I try this at home, I will have a problem. I guarantee you.
Yeah, absolutely. You're going to run into problems. And basically it shows as an error, just like it would any other store procedure. You'll see it in the results message. So what you could do is you could actually take that script, use it in another code editor, refine it, and then once everything is said and done, you can paste it into here, or just work through the errors all through Management Studio.
Okay.
Unfortunately, it doesn't have the rich debugging environment like you would with other tools. But you're able to execute the script directly from here. Does that answer your question?
Yes, it does. Thank you.
I know it's not the ideal answer, but like I said, the The IDE, I'm sure, will be improved in the upcoming few years.
Yeah. Yeah. And is this also available in Azure SQL Server?
Only for managed instances.
Okay.
Okay.
Mhm.
Any other questions? So where could this be useful? We were talking shortly before the start of the meeting of how this could apply to our day-to-day lives. Let me rephrase it. Our day-to-day jobs, rather. What some of the things that this could be applied to? Rochelle, do you see it as being a fit for what you're working on?
No, not at the moment. Like our software is mostly just using for people to like directly record things um like benefits, but maybe it could be useful for like budgets if like just for funsies I wanted to present a graph and try to predict what all the departments are going to ask for spending.
So that's certainly one aspect where it could be applicable. Another thing is, as you had seen, where we're using it to predict prices of certain items. So, we could also use it to plug in values for prices that our competitors are selling a similar product. And then we could see what kind of a trend that is developing, and we could likewise raise our prices accordingly to match that trend. So home prices was, just a brief example of it.
I have a quick question. When you say plug in like competitors' pricing, is there like a way you could, what's the word I'm looking for? Scroll through eBay, I'm sorry,
Ooh, a
I've been at work
scraper.
all day. Yeah, and kind of pick those prices out, and then input that and to kind of get that competitive pricing. I'm just curious.
You could
Scrape,
absolutely, and
that's
and
it.
I and scrape is the key word there. Yes.
Had a long
So that
day.
would so not only would you have to scrape the data, but another
Yeah.
key aspect is scrubbing the data, meaning that I want to make sure that the model's a bad word, that the item that I am matching on eBay is very similar to the item that I have. I don't want to match a Cadillac to
Hmm.
a 78 Buick, for example, right? I need to be very close in the features and what's provided by that item. So I would have to make sure that my data is cleansed and it matches what I'm looking for. But yeah, once you gather that, then you can have it into a table, and then you could run this type of thing against it.
Yeah, that could be very useful. I'll definitely probably come back and watch this recording, see if
Sure.
I can automate some stuff.
Yeah, absolutely. Now the gears are starting to turn. I like this. This is good. I also like the interactive conversation. So again, feel free to jump in with questions or comments.
So I have a suggestion on how we can use this, how Rochelle could even use this, because she mentioned that she thinks that, oh, maybe we could use this for logging. So if you had event logs and you had a type and like a date timestamp, you could count, right? So you could use this to predict like how many of these log errors would happen. And you could do like anomaly detection, like, oh, today it was way more than usual for this type of logs, right?
Yeah, absolutely. So anomaly detection is one aspect of it. Um, yeah, there's you can also see when, as we talked about earlier, um, if there's a specific error that occurs more often than not. Sometimes it's hidden to the human eye, but when you sit and you graph it out, or you see specific trends where a specific error surfaces, Thursday evening at 8 o'clock, for example, then it might cause you to look into it further and see what else is going on to cause that error to be triggered. Make sense?
Yeah.
I'm not sure. Can you say that again? So you could like you don't need AI to find the error that you're expecting. What would you using AI for? To find out what else is happening around that time?
So I would be using it to find out if a specific error happens more often at a specific interval or a specific time than other errors,
Oh, okay.
right? And if that's
Yeah,
the
that would
case,
be
then it
cool.
would trigger that I need to look into something a little bit further, go beyond that.
All right. And how does AI differ? So like I feel like if we took the data that like you plugged in or like my error data and simply made a graph with it, a line graph, um, that would give us pretty similar answers. So how is AI more helpful than just graphing the data?
So in that specific scenario, that graph is basically a visual representation of everything for that specific time span,
Mm-hmm.
right? And however, when you're using AI, you can use it for its predicting capabilities. Meaning, obviously, maybe I want to predict how many errors I'm going to be getting next Thursday, for example. So I can use it for that. But even more meaningful is looking at something like housing data or the price of items that I'm selling to see, I can understand if it's an 1100 square foot home sells for $98,000, right? But what if I'm selling a 5,000 square foot home? How do I know what the price is? And then to complicate things even more, let's say that it's 5,000 square feet, but has 6 bedrooms and a swimming pool and a variety of other things. How does that compare to all the other data that I have?
Okay.
AI will be able to
Yeah,
predict that value much quicker than a graph could.
for sure. Like, yeah, when we start adding more data points, that
Right.
definitely AI would be the way to go.
Yeah. Now keep in mind, this was a very brief and simplistic example. I don't like to inundate people with all the details when I'm introducing a new concept.
Oh, for sure, for sure. Sorry, I did not mean to like
Oh no,
minimize
no, you're good.
what you're doing. I was just like thinking like, oh, I could just, plot the trend in my head, like, but AI could do something much more complicated than that.
Yeah, no, you bring up a very good point. Yeah. And actually, I mentioned in a course that I was doing that when you're using visualizing tools, it gives you a good representation of the data overall, and you can see outliers, anything that may need to be addressed individually. But when you want to make a prediction, this is definitely the way to go.
Cool.
Any other questions or comments? All right, very good. Let's see where we're at. Okay, so getting back into our slides. So as we mentioned earlier, yes, there's a variety of different scenarios available. So we talked about the linear regression, but you can do classification and categorization, where you can actually take an image and then you can classify or categorize it to see if something fits. Is it a fruit or is it a vegetable? What type of fruit or vegetable it is? Um, you can use anomaly detection, as we had discussed in our conversation just a few minutes ago. In addition, you can use it for recommendations. So you probably heard of a website called Amazon.com, right? Wherever, anytime you make a purchase, there's always something else that it is recommended to go along with it, right? And I say that sarcastically because chances are that's where half of our paycheck goes every month is through Amazon. But yeah, every time you make a purchase, there's a recommendation. Hey, now that you bought a lawnmower, how about an edger to go along with it? You bought a cell phone, how about a case to go along with it? So these recommendations can also be done using AI models. In addition, we could use it for time series or sequential data. So if we're looking at sales forecasts, we can use it for that as well. And image categorization or classification, we already talked about that earlier, but we can use that in the medical field where we can study images and be able to identify is something precancerous, is there something that needs to be addressed on a higher clinical level. So it can help facilitate this as opposed to having to rely on a human eye, and of course, human error would play a part into that. And so moving right along, going into our next demo. So this is going to be an iris demo where we're going to take a look at various measurements of an iris. And as we see defined here, there are two separate parts of the iris that define which type of iris it is. So we have the petal and the sepal, and then depending on the measurements of those items, it could be either a setosa, a versicolor, or a virginica. And so with that, let's take a closer look at another demo. And so here we have a table for the irises, and let me change databases. And I'm going to drop my table and then recreate it. So again, to make sure that we're starting with clean data. And likewise, I also have a table called iris models, and I'm going to drop that and recreate it. And looking at my iris data, it is currently blank. And so this store procedure basically will populate that iris data. So we'll go ahead and actually that's already created. So we'll go ahead and execute that. And so what this is doing, it's populating specific data for the sepal and the petal into my iris data table. And that should just take a minute to populate. And a great time to take a break.
How much data is in that set?
Good question. So when we do a selection, we have 150 rows. And as you can tell, it shows different measurements for the sepal length and width. Likewise, the petal length and width, and then the type of species that it would be defined as. So we gave it a species name and a species ID, and it all revolves around these four columns, the length and the width for the sepal and the petal. With me so far?
Yep, I'm here.
Okay.
Yeah.
So basically, this is just a starting point of the data that we're going to be using. And again, this is just sample data. But looking more into it, the whole point of this demo is to show that it is no longer just linear regression, but it is categorization based on a variety of different features. So we have four different items or four different features that will define a specific species. So how does that get incorporated into an AI model? And so for that, we're using a store procedure where it's going to be generate iris model as the name. And then likewise, it's going to output a var binary max as the trained model. And just like we did in the previous example, when we execute the store procedure, it's going to take that model, which is a serial, and then produce a model out of it. And it's going to store it into the database as a serialized string or a var binary max. So because this involves categorization, what we're doing is we're utilizing a different library, and this is the Gaussian naive Bayes from the sklearn naive Bayes module, and we're importing the library. And then from here, we're specifying the data frame, which is going to involve these four fields. So it's going to look at these four fields, and then the target is the species ID. So here's where we're training it, and then it's going to output a model. And then when we execute that, so it's going to get trained on those four fields, and then it's going to produce a model, which will then be imported into the iris models table. As we see here, insert into iris models, and it's referencing the model that we generated. And so if we look at the iris models, you'll see that I have the model name of naive Bayes. That's the model that I trained it on. And then this is the actual model itself. Everyone with me so far?
Mm-hmm.
Okay, very good. So now that I have that model, I need to be able to use it to make predictions. And so similarly, as we had done with the house prices, it's going to create another column for predicted values, and it's going to output it next to all the other columns that we have. And so it's going to do that using a predict species store procedure, where we're going to pass it in the model name. And as you see what it does here, it selects from the iris models table and it gets that model name. We specify that we're going to be executing a Python script. We do our importing of our libraries here. And then we specify that it's going to be looking at these 4 fields. And then the output is going to be a predicted species value along with the ID and the species ID. So that is the output data set that is going to print out. And so when we execute the store procedure, sorry, this is the portion that we need to execute. So we're passing in the name of the model. It's going to call the predict species store procedure, which is this one. And then that's going to output the results. And we'll go ahead and run it. So as you see, we have the ID field for all the records. And then for each one, we have a species ID. And now we have a species ID predicted. And so when I scroll through the list, you'll see that it's almost a one-to-one correlation. Granted, there are some error values here. So this one here, it predicted a value 2 when it was actually a species ID of 1. And there are still some errors that are scattered throughout, right? But for the most part, we're almost a one-to-one match. Now, when I see something like this, depending on the number of errors that I can tolerate for my specific scenario, I may either choose to retrain it by providing more data, excuse me, or maybe it's something that I can live with that error level, again, depending on what I'm working with. Okay, but this was a scenario where we took 4 different features, sepal length and width, and then petal length and width, and be able to identify a specific species and then have a predicted species that's produced out of it. Okay. Any questions on that?
Yeah, I have a question. So for this scenario, everything was hand measured and entered into a database, right?
Right.
Okay, so this is like the step before we get to the really cool stuff, right?
Yeah, so what I did up here was basically that data was housed in a Python library. And so this store procedure get iris data set, all it did was go into these libraries and then populate that table. So I extracted that data essentially.
Okay. I was thinking, so how big of a stretch is it to take from something like this to like when you're actually scanning images?
So this one is not working with images per se. It's looking specifically at the measurements.
Right.
So if you're working with actual images where you're submitting a picture, let's say that, here I'm holding my cell phone up, right?
Mm-hmm.
You want to be able to identify a face in the picture, be able to identify a phone. That's a completely different library that you'll be using for that.
Okay, I'm sorry to derail.
No, you're not. You're good. Like I said earlier, there's a variety of different algorithms that you could use, but each one is going to be in a different library.
All right.
Okay. What other questions can I answer?
Can we look at the actual store procedure that builds the model?
Sure.
I just have a question about how I've never done Python in SQL Server. I know it's possible, but how we parameterize that. So scroll down.
So this is the stored procedure as a whole that gets the data sets. The items that you see in red is the Python script.
Right. If you go down to the other stored procedure that builds the model, yeah, generate iris model. So here we have this, maybe it was another one. So we're creating this. So you're sending the trained model, and then that's just the output though. Okay. So the trained model output is what you're returning the trained model, which is the input. How does the trained model get loaded?
Well, the trained model is passed in, but it's a variable that's going to be, basically think of this as an empty variable because it's going to be used as output. So here, my store procedure, this generate iris model, this is just for creating it. Where it's actually used is down here. And if we go through this step by step, we have a variable called model. That's a var binary max type. Pardon me. Another variable called new model name. And we set that to naive Bayes. And now we execute the generate iris model, which is the store procedure up here on line 87. And we're passing in the model variable, which is just an empty variable because it's going to be used for output.
Yeah, and then how does that get assigned in the stored procedure? So I see you have the script that runs.
Right.
And then the input data is the select, the data name is set. So that, yeah. Like, I guess is that just magic?
No, on line 100, that's where it gets set.
Okay.
Add trained model, add trained model. Pardon me. And that's where it's set up up here. Excuse me.
Oh, that's where it is. Okay.
Sorry about that. Yeah.
Got it. Thank you. I
You're
was
very welcome.
following that and I was like, where does that actually happen? That's where it happens. Thank you. It's the red. It's throwing me off. Got it.
Very good. Do we have any regular Python users in the group? Maybe
I'm kind
not.
of just getting started in Python.
Okay. And what's your tool of choice for editing Python?
Whatever we use at work. I'm not quite sure.
Okay.
I'm also using Python. I either use VS Code or PyCharm.
Oh yeah, I use VS Code.
I also use VS Code.
Yeah, so like I said, you could use it to refine the script outside of that, meaning you would, focus on this portion of it and then just cut and paste it into the store procedure when everything's done to get a richer debugging experience. Okay, any other questions, comments? All right, so moving right along, if we're looking to improve performance overall, as you had seen in that last demo, there were some of the records were erroneous, where we predicted a value of 2 when it was actually a value of 1 for the species ID. So how do we improve that? Obviously, more data, but not just more data. You want it to be clean data, meaning you want to go through it, make sure that there are no outliers, that there are no null values, and that the data is cleansed. More importantly, you want to look at data with context. So, going back to the first example that I did, we just looked at square footage and the price. Obviously, we left out a lot of that. In reality, zip code is one of the key features for the price of a home, number of bedrooms, bathrooms, the condition, whether there was fire damage or termite issues. And so that's what is meant by context. If we can better identify more features around that final predicted value, the better our outcome will be when training a machine learning model. In addition, you can utilize different algorithms to be able to help identify really what's the best type of model to develop out of this. Some gotchas. So with SQL Server, you have the ability to run it both on Windows and Linux. However, there's a couple of gotchas there depending on if you're going to be using the Launchpad. And if you recall, the Launchpad is what allows us to be able to launch an outside or an external script call. And so if you're running it in the Windows world, you're limited for one Launchpad per database, as opposed to in Linux, where it's at one Launchpad per user. Similarly, the SQL Satellite process in Windows, it inherits the account privileges of the account that you're running in, versus in Linux, where it utilizes the low privilege account available. And so some things that don't always jive there, so you'd have to take a closer look at your specific installation. In addition, we've all seen the error where when we go to spin up a SQL Server Management Studio, and it says the database is not available. So naturally, you go into the configuration services, and you're able to start it up or start up that service for the SQL Server agent. Likewise, you can have a similar issue with the Launchpad. And again, same thing. You go into Configuration Manager, and you would start that service as well. So a couple things to watch out there for. Now, generally speaking, I would like to hear your feedback. What is it that you learned here today? If someone asked you, what did you spend the last hour on? Was it beneficial? I would like to hear what's your feedback.
I would
guess-
say yes. The last hour was beneficial.
Mhm.
Thanks. But more importantly, what specifically did you learn?
All right, I'll go because I already went and I talked over Emily. Sorry, Emily.
Oh, no, you go.
Well, so I learned how to use Python in SQL Server, and that really ML in SQL Server is Python in SQL Server, which is cool. I learned that I'm going to play with it and do lots of cool things with it.
Well said. Now, if you want to play with it, what are some of the things that you have to do for the installation? Let's see how well our memory works in relation to the slides that we covered before. So what do I need to do in the installation process? And this
Pull
goes
up
for
the
anybody.
recording.
Go
Pull up
through
the
the
recording
recording. Good
and go through the
answer.
slides again. That's what I will do.
Very good. What else? So if you recall, we said that you had to install, obviously, SQL Server. You have to install machine learning services, right? But not the standalone version, because we want to incorporate it with our database. Then I had to install my Python and R libraries. And there was a checklist that I presented that you had to go through depending on your specific installation scenario. And it also depended on which version of SQL Server you have and which version of R or Python you can install. The last step, the fourth step, anyone remember? Notice I said the last step, right? The fourth step.
Don't you have to turn the external scripts on, right? You have to go into
Exactly.
config.
External scripts enabled, and I do that by the sp configure store procedure. I set it to a value of 1, and then I'm off and running. Excuse me. So a good answer. What are some advantages of using AI with T-SQL? Anybody?
You don't have to move your data.
Right. More specifically, I have integrated functionality with Python and R libraries, right? What's another advantage?
You can, yeah, that.
That one, there you go. I thought I'd give you a hand. So I can use T-SQL, right? A language that I'm familiar with, in an environment that I'm familiar with in Management Studio. As Shannon mentioned, I don't have to import any data. Everything's already there. And because I'm utilizing T-SQL, I have full functionality over the entire life cycle of the model. Training, testing, I can store it into the database. and then I can use it for evaluation and prediction afterwards. Okay. So some references that are available. There's some great write-ups over on Microsoft Learn, and some great examples as well, and some great quick starts. And then depending on your specific scenario with user permissions and whether you're running Windows or Linux, there's some documentation there to help you through it. If you're interested in this as a course, we do offer that at NIS Technologies. That's available as a course. If you're looking to get in touch with me later, I'd be more than happy to answer any questions. Like I always say, just because it's the end of the meeting doesn't mean the dialogue stops here. Feel free to email me. I was actually in a dialogue with a gentleman earlier from New York who viewed one of my previous presentations, and we were shooting ideas back and forth all day. I invite you to do the same if I can help you, to be able to get a better grasp on this, to be able to set up a test environment. Nothing would make me happier. You can find all my information over on Linktree/Sam Nasr. And more specifically, my email, snasr@nistechnologies.com, my Twitter handle, and if we're not connected on LinkedIn, I invite you to do so. And so with that, thank you for attending and thank you for having me, and hope it was fruitful.
Thank you, Sam. That was awesome.
Thank you. Appreciate it.
Does anybody have any final questions for Sam? Or just comments on the presentation at large?
No, I thought it was great. Gave me some ideas.
Excellent. Thank you, Emily.
Yeah, this was great. Thank you, Sam, and thank you, Shannon, for putting this together.
You're very welcome. Thank you.